already used this new 3D printing technology, but we did not know how it could be used within our high-quality standards.
DirectSpare has really boosted the development of critical pieces of the product.
DirectSpare was not just about making parts, but about every aspect a company has to consider when it chooses to implement this new and sustainable way of providing spare parts.
The question all that our group members had was, how can we implement this new technology into our businesses to create great advantage for our customers?
In our search for the right way to adapt and develop additive manufacturing, we have found a way to incorporate total quality management. High quality standards are crucial.
Current technology allows us to develop and produce many kinds of products through digital printing. Now, this may sound odd, but this technology exists since the 80s. By sending a 3D file to an oven kind of machine, virtually every kind of product can be printed layer by layer. This technology has been developed over the years, and by using different kinds of techniques, today products can be printed from many kinds of materials, from plastics, concrete, and even steel. This is a production process that allows us to manufacture parts by printing, sintering, or melting.
The additive manufacturing offers a new freedom of design, and together with the availability of new materials, we will have new exciting applications for plastic materials.
With the cubic method, you can print small parts in metals like stainless steel, copper and titanium. The properties of the components are similar to those produced with traditional methods, and spare parts can be produced from existing drawings without tools.
In recent years, the technology has made the transition from prototyping to real manufacturing, thanks to great achievements in material, process, and software techniques.
A few years ago, I was driving one of my cars. It's a classic car, and one of the parts broke down. And at the time I came with the idea, hey, maybe I can make them with modern technology and modern additive manufacturing technology.
Additive manufacturing offers us a huge geometrical freedom. The use of additive manufacturing really becomes powerful when you don't just copy old designs made for traditional processes, but when you optimize your new design so that you can use all possibilities that additive manufacturing offers.
By using this technology, a wide range of new products can be made easily from scratch to print. But what if old products have to be printed again? And what if these older products have to be printed in a series and have to apply to high industrial standards? Would it be possible to use 3D printing?
Right, your headlight cover is broken and it needs to be replaced. Normally I would have to check where I can buy it, ship it, and then check the prices. But using our DirectSpare concept, we can produce it ourselves.
The cool thing is that we now instantly produce a new or spare part. All you need is a 3D model of the part you need, and the part can be printed. Even if there is no 3D object, the spare parts can be scanned on one place and even repaired or improved and be printed on the other side of the world.
Additive manufacturing works for many industries, such as the automotive industry, the medical industry, and even in aviation.
Adapting additive manufacturing means having a look on the entire process chain and not only looking onto the machine. Machines and process have to be more reliable, more predictable, and need a certain traceability in order to be a valid technology for our customers' needs.
By rapidly manufacturing spare parts, it is possible to instantly deliver the product. It's quick, saves stock, and precious time. Waste of products is cut by 30 to 80%. Stock is no longer necessary, and transportation and storage is no longer needed. Producing existing products within existing quality standards requires a much more dedicated approach. 15 companies in Europe, in a wide range of disciplines, have been doing research for 3 years in order to find out if the dream can come true. With the support of the European Commission, all these companies have been able to bring together some of the best experts in the fields and have demonstrated that additive manufacturing can be used for producing spare parts.
Our ambition was to set up a technological system supported by new business models that would enable OEMs to provide original spare parts for their equipment worldwide.
Well, the drive pedestal, which we see here in the picture, was provided by Bosch Siemens, and these parts typically break. The challenge in the Direct Spare project was to have this part redesigned such that it can be actually 3D printed, and this typically does not work since this part comprises two different materials, one of which is plastic material and the other one is rubber, which fulfills the function of damping. We changed the design, and rather than using material in order to fulfill damping function, we use design and structure, as you can see in the picture. This is what we did to this demonstrator part.
Eurocopter selected a common support part as a test case. We decided to take this part because it came from an old helicopter called Alouette. And this part represents a typical example of a spare part because we are no longer producing this type of helicopter. And there are no 3D models existing anymore, and the molds are no longer available.
With Direct Spare, we choose the gimbal, which is quite a challenging part in the system. In the past, we designed this part and we manufactured this part in composite. With the new system, we wanted to be more free in terms of design and also to be able to produce in series.
As a test case, we chose two parts. As a plastic part, we selected a headlight cover, and as a metal part, we selected an ornamental grille.
The Direct Spare Total Quality Management System is based on long-term applied research and practical experience. It is holistic and covers all aspects from design to final inspection, from equipment to material and traceability.
This needs also, from the designer's point of view, a change of mindset because you have total geometric freedom.
In Direct Spare, we are looking on the whole process chain of these parts. For example, we are investigating different scenarios, different business models, and at the end we can answer to questions of the customers where it makes sense and where it doesn't make sense to produce a part like in Direct Spare project.
In principle, producing spare parts would require the same quality and standardization norms as other parts. So in that sense it's the same. However, we know spare parts on demand cannot be tested because we only have one, and that's a big difference.
We printed this part according to the original drawings. This part is exactly the same as original part.
The process of on-demand and on-location production of spare parts is very easy. The company locates the spare parts, sends the drawings or specifications to a location with a printer. The product is being made and can directly be sent to the customer. Is this a dream, or is this reality?
But our Direct Spare partners developed so many interesting things that I think that we can solve the existing obstacles and the dream can become reality.
So the Direct Spare project, the concept, will become soon a reality.
The reality is that additive manufacturing can be used to produce spare parts. The dream part is that companies now have to adjust their business models to make full use of this new technology.
Today, Direct Spare is a reality for Eurocopter. We have been using rapid manufacturing for a few years, and being a partner of the project provides means and understanding on how to control the total supply chain of spare parts.
With additive manufacturing, it is possible to improve all three aspects of manufacturing. Therefore, it should become reality.
Looking at all benefits of this business model, I am sure that companies will implement it in the near future.